If the AMAROK's differential is defective, it's no longer necessary to replace the whole rear axle. You can now perform repairs on the rear axle drive. However, before starting repair, some preparatory measures have to be taken.
Firstly, the wheels and the brake drums have to be removed from the rear axle. Then remove the prop shaft to be able to remove the differential from the housing. Drain the gear oil via the drain plug. Now remove the cover and the cover seal. Then loosen the inner securing bolts of the axle shaft. On the other side, install a socket head bolt M14 of a length of at least 120 mm and a lead of 1.5. Use any screw in the anchor plate as forcing screw. Use it to force out the axle shaft. Then remove both axle shafts on the right and left sides. To be able to perform repairs on the differential, it has to be removed from the final drive housing.
To remove the differential, screw off the bearing brackets. For vehicles without a differential lock, you should apply a colour marking on the bearing brackets to be able to reinstall the right one on the right side and the left one on the left side. This is not necessary for our vehicle here because it has a differential lock. Here the differential lock has this cable set with the screwed cable gland, which is always on the left side. The screwed cable gland is provided only for the bearing bracket for vehicles with a differential lock. Therefore, the brackets cannot be mixed up.
After you have removed the bearing bracket, disconnect the connector from the differential lock. Then remove the retaining bracket of the connector. Now attach expansion tool T521. Always use new screws and washers because the expansion will stress the bolts up to the shear limit. The screws have a tensile strength of 12.9 and can be ordered from the electronic parts catalogue ETKA. When you use the expansion tool, always wear safety goggles because the screws will be under a high load. With the expansion tool, you expand the differential housing. Expand the housing until the crown wheel can be removed together with the differential. Ask a colleague to help you during this work step. Remember during removal that the connector of the differential lock is forced through the housing. After removal, the expansion tool can be removed again. To remove the pinion shaft, unlock the securing nut first. Then attach counterhold tool 3145 on the prop shaft flange. Now loosen the securing nut. Mount the splitter on the flange. Pull the flange off with the puller. Then drive the pinion shaft out of the differential gear housing. After having removed the oil seal, remove the outer pinion shaft bearing. Now remove both bearing shells of the pinion shaft with a driving punch. First, remove the outer bearing shell. And then the inner bearing shell. The differential is dismantled as follows. Use a puller to force the pin out of the differential. Screw a nut on the tip of the spindle to protect the spindle. Then force the pin out with the puller.
A locking pin locks the pin in the differential. We just forced out the locking pin. The pin is taken apart in 3 pieces. One piece falls out immediately when the pin is pushed out. The second one remains in the differential housing and can be driven out. The third piece remains down here in the differential housing. It is important to say that we have a tapped blind hole here. This means that there is no way to get this piece of the pin out again. This is why we can only replace the pin a maximum of 3 times. Then the bottom hole would be simply filled completely and no locking pin could be inserted anymore. Some older differentials do not have this bottom hole. For these differentials, a shorter locking pin must be used because it cannot penetrate into the bottom housing.
When the pin has been removed, the bevel gears can be pushed to the sides and be removed through the openings. To determine the causes for disturbing noise, for example, visually inspect the components. Check the bearings, gears, and the guide ring for damage. Also check the teeth of crown wheel and pinion shaft. If you find any damage here, always replace the crown wheel and the pinion shaft as well. Some background information. Pinion shaft and crown wheel always have to be changed together because they are matched with one another. If you now find any defects in the visual inspection on the crown wheel or the pinion shaft, always replace both components. When removing the gearshift actuator, you have to remove the bearing. In doing so, the bearing cage will be opened and therefore destroyed. Then mount the puller. Pull out the inner ring. Then loosen the actuator circlip. And take off the actuator. Now visually inspect the guide ring. If you find that a plastic tab is broken off, as in the example here, replace the guide ring. Check the thrust piece on the gearshift actuator. If a tab is damaged here, also replace the whole thrust piece. The gearshift actuator can be function tested. For this purpose, connect the gearshift actuator to a 12-volt battery via the VAS 5260A. If current flows through the actuator, it switches. After the checkup, start to assemble the differential. First, the shifting claw is joined with the bearing ring, which is probably a new one. Then install the return spring and then the bevel drive pinion. Install them in the housing. And then install the 2 differential bevel gears, the second bevel drive pinion and the pin. Use a locking pin to secure the pin against slipping out. Then mount the actuator and the circlip afterwards. Now the new bearing is pressed on. For this purpose, use the respective pressing element. Even if only one bearing is replaced on the pinion shaft, It is always necessary to redetermine the thickness of the shim. For dismantling, you need to force the larger bearing off the pinion gear with the hydraulic press. Then you get to the shim, which you will redetermine by measuring. The shim thickness influences the pinion shaft position. The first step of measurement is to pull in the new bearing shells of the pinion shaft bearing assembly. For this purpose, use the threaded rod T523 and the two fitting tools T548 1 and 2. First, the large bearing shell is installed using the respective fitting tool. Then install the smaller bearing shell with fitting tool T548 2. Measure the housing with measuring tool T547. Basically, the tool is made up of a measuring head, master gauge, and two extensions of different lengths for a dial gauge. In addition, you need dial gauge VAS 6079. Use the short extension to extend the measuring tip. Now insert the dial gauge in the master gauge. And place the master gauge with the flat side on the measuring head. Set a preload of 2 mm. Then secure the dial gauge in the master gauge. Set the dial gauge to 0. Then use the knurled screw to fix the measuring scale. Now place a new large bearing of the pinion shaft on the measuring head. Insert it now in the differential gear housing. After having performed these preparations, first turn around the small thrust piece of the puller tool. Now screw the measuring head hand tight in the differential gear housing using the threaded rod. By slightly turning the master gauge, you will determine the dead center or the return point. Read the measured value from the red scale. In this case, the reading is 59/100ths of a millimeter. Select the shim of the measured value. The pinion shaft is now assembled. Place the selected shim on the pinion shaft. Then press on the bearing.
When you install the pinion shaft, please always use a new upsetting sleeve. And apply a sealant on the longitudinal gear teeth. Ensure that all possible remainders of the old locking fluid and sealant have been removed completely.
For background information, for each replacement, replace the upsetting sleeve. The upsetting sleeve sets the preload between both bearings. If the flange nut is tightened too much, the upsetting sleeve is overstretched. Thus, the bearing preload is not ensured in operation. In this case, you will have to remove the flange and bearing again and replace the overstretched upsetting sleeve. The pinion shaft is inserted in the housing. Install a new small bearing from the other side. Then mount the oil seal and fix it in position. Please ensure that the oil seal is flush with the flange. Now mount the flange. Now screw a flange nut so tight that the pinion shaft has no backlash anymore. The coefficient of friction can be set now. When new bearings have been installed, it is the range between 2.52 and 2.82 Newton meters. You will reach this value by measuring and screwing alternatingly. For background information, the tighter the flange nut is tightened, the harder the bearings will turn, This will cause overheating. If the coefficient of friction is set too low, the resulting backlash is too big. In both cases, the bearings would be damaged. Objective in the installation of the differential is to determine the dimension of the shims to achieve proper backlash of pinion shaft and crown wheel. The backlash results from the distance of the pinion shaft gear teeth and the crown wheel teeth. To determine the shims, install both bearing shells and measure the axle dimension of the differential. Measure the housing inside dimension next. Use measuring element T547. Use a feeler gauge to determine the gap between the master gauge and the differential gear housing. The calculation is done as follows. The measuring element has a fixed dimension of 212.50 millimeters. Add the measured gap size of the feeler gauge to this value. To the total of these figures, add the fixed value of the bearing preload, which is always 0.03 millimeters. From this sum, subtract the axle dimension of the differential. Now you determine the total dimension of the shims. Divide it by 2. Now select 2 shims from the list of the workshop manual, which in total correspond to the determined value. The shims determine to which extent the spacing between the pinion shaft and crown wheel varies. Use the expansion tool to insert the differential in the housing. Remember to put the connector of the differential through the housing opening intended for this purpose. Insert now both bearing shells and shims. Fix the differential in position with the 2 bearing brackets.
The calculated dimension of the shims must always remain the same. However, it is possible to distribute the dimension in different ways on both sides. This means that if we use a slightly thicker shim here, we have to use a shim there which is thinner by the same dimension. By shifting the differential here, we set the tooth flank backlash. It is checked with bluing compound.
For background information, the rock or backlash between the pinion shaft and crown wheel is specified in the workshop manual. It is determined by the support of the pinion gear on the crown wheel and set by the shims. If no backlash or too large a backlash is set, the crown wheel teeth or pinion shaft teeth will always be damaged. The tooth flank backlash results from the distance between the crown wheel and the pinion wheel. If the distance is too small, increased wear will result. If the backlash is too big, disturbing noises will be caused. Measure the tooth flank backlash with a dial gauge. To do so, screw the dial gauge retainer on the housing. The measuring tip should be placed as vertically as possible on a tooth flank. Then set the scale to 0. For verification, move the crown wheel from stop to stop. The tooth flank backlash must be between 0.1 and 0.177 millimeters. If the tooth flank backlash is too big or too small, the shims have to be redistributed. The seating pattern results from the position of the pinion shaft and the correct tooth flank backlash. Use bluing compound to check the seating pattern. Use a brush to apply the compound on 2 or 3 teeth of the crown wheel. When you turn the crown wheel, the impressions of the gears can be seen. In this case, the adjustment is perfect. If the seating pattern is not correct, correct the position of the pinion shaft and the tooth flank backlash. When all the settings on the rear final drive are correct, the differential gear housing can be reassembled. Always use new seals here. Then reinstall the cover. Reinsert the axle shafts. Attach the brake drums and wheels. Screw the prop shaft on the differential gear housing and fill in new oil. When replacing the actuator, the new Hall sensor has to be adapted. To do so, go to Guided Functions, Basic Setting of the lock electronics. For background information, the differential lock control unit detects 3 control states via the Hall sensor. These are open, tooth to tooth, and differential locked.